Welcome to part 4 and hopefully the final video for chapter 5, day 6. All right, we're going to go ahead and take a look at the last few examples, and hopefully you guys will have a little better idea of how to do these problems. Now, just a reminder, what I would try to do, guys, is pause the video before each example, see what you come up with on your own, and then you can check your work compared to what we do. So, for number 9, we want to write a limit of a Riemann sum to represent the exact value of the integral from 0 to 2 of x cubed plus 1 dx. Again, same thing, just a little bit different wording. So, we're going to start by identifying delta x. Delta x is b minus a over n. So in this case, 2 minus 0 over n, which is 2 over n. Your next step is to find f of a plus k delta x. So, specific to this problem, that is f of 0 plus 2k over n. Again, 0 is coming from the lower limit, and the 2k over n, we're taking k and multiplying it by our delta x value. So 2 over n times k is 2k over n. From there, we need to, again, that can simplify in this problem to just 2k over n, and f of x is this function here. So we have a value being cubed plus 1. Now, the value being cubed is 2k over n, and that is going to simplify in this case to 8k cubed over n cubed plus 1. At that point, we have the two quantities that we need. We have f of a plus k delta x, and we have delta x. So we're going to go ahead and write our limit. The limit as n approaches infinity of the sum from k equals 1 to n of our function here, which is 8k cubed over n cubed plus 1 times our delta x, 2 over n. And that's what we do. All right, we'll move on to the next example, number 10. All right, which one of the following limits is equivalent to the integral from 3 to 5 of x to the 4th dx? All right, multiple choice in this case. But again, we still need to find delta x. So delta x in this problem, b minus a is 5 minus 3 over n. So we have 2 over n. Now, again, one of the things I mentioned in the previous video with the first example was sometimes you can eliminate some of your answer choices based on delta x. So a has delta x of 1 over n, so that can't work. So does c. So we can at least eliminate a and c based on that information. We still need to find f of a plus k delta x. All right, now you want to pay attention here. This time, we are not starting at 0, we are starting at 3. So this is going to be the same thing as f of 3 plus 2k over n. So now when we plug into our function, all right, we have something being taken to the 4th power. Well, that something is 3 plus 2k over n. Most of the time when you have an exponent, that's larger than 3 or 4, or, larger than 2, so 3 or 4, many times they're just going to leave it in this form without expanding it. So that's how the answer choices are written. If I were to write this out, we'd have the limit as n approaches infinity of the sum from k equals 1 to n. All right, here is our f of a plus k delta x, so 3 plus 2k over n to the 4th power, and then our delta x is 2 over n. And we narrowed it down to b and d before. If we take a look at b, it looks good until we get to the k. It should be 2k, so we can eliminate b, and d is what we are looking for. All right, if we take a look and move to 11, again, I pause the video, try it on your own. We're going to start with delta x, which in this case is 0 minus negative 2 over n. Again, we simply get 2 over n. Now, over here, all of our delta x values are 2 over n, so that doesn't help us eliminate anything. So we're going to go find f of a plus k delta x. So in this case, I'm going to skip that step. Hang on 1 minute, guys. All right, guys, sorry for the interruption. So now, if we go through here, it's a plus k delta x. Well, in this case, our lower limit is -2. So it's -2 plus k delta x is 2k over n. So now when we go to our function, all right, we got to be a little bit careful here because we have 3, we have a x being squared, and then we have 2 being multiplied by x as well. So now what we're going to need to do is within there do -2 plus 2k over n, -2 plus 2k over n. At that point, when you look at the answer choices, I don't have anything that looks like that. They're all expanded. So let's work on expanding this out. All right, I'm going to leave the 3 alone in front. We're expanding this binomial. So we're going to do -2 times -2, which is 4. We're going to multiply -2 by 2k over n twice, which is going to give us, what is that, -8k over n. And then we're going to have 2k over n multiplied by itself. So that's going to give you positive 4k squared over n squared. Over here, you're going to distribute the 2 to get -4 plus 4k over n. That's a 4. All right. We got to keep simplifying. So we're going to distribute the 3. That's 12 minus 24k over n plus 12k squared over n squared minus 4 plus 4k over n. All right, you can kind of see it's involving a little bit of work. Now, if we simplify this down, all right, I'm going to come off to the side right here. So you have 12k squared over n squared. If we combine the -24k over n and the 4k over n, we get -20k over n, and then 12 and -4 combined to 8. So this expression here is our f of a plus k delta x. So now we want to look for which of these has that expression in the parentheses, and quickly go through and eliminate. Here, I'm not sure on yours if the k is there. It's missing off the digital copy, but we don't have the plus 8, so that's out. If we look at B, it's 3k squared. That's not right. Looking at C, we got 12k squared over n squared minus 20k over n plus 8, and then our delta x was 2 over n. That looks good. There's our answer. So again, it really comes down to being able to find the delta x and the f of a plus k delta x value. You get the hang of that, it'll start, you'll at least be able to get where you need to go. All right, now the next example I find a little bit harder because when we take a look at it, we're given that limit and we want to find the integral. And sometimes it's a little more obvious than others, but this one's a little tricky. So first thing I would do is I would look at what the delta x value is, 5 over n, and see if we can eliminate any of these. Well, the limits of integration all have an interval of 5, so we're not going to necessarily be able to eliminate any from there. So the next step would be, to see if we can find which one is going to have the f of a plus k delta x value here. So that kind of becomes the key. So for A, all right, so looking at A, if I did f of a plus k delta x, this is going to be f of 0 plus 5k over n. And if we substitute in, that's 4 times 5k over n, which would give you 20k over n. Well, this value is not what's in the parentheses. So A is out. So if we check B, same idea. We want f of 0 plus, it's k delta x. So again, it'll be 5k over n. Well, this expression is 4x plus 1. So we're going to do 4 times our 5k over n, and then we have plus 1. 4 times 5k over n is 20k over n, and then we're adding 1. That looks good. That matches. there's the answer. All right. If you went through the additional choices, you wouldn't see that they do not give you the correct f of a plus k delta x. So again, being a multiple choice problem, sometimes using that process of elimination is the best way to go. All right, guys, I hope you found this video helpful. Again, these are some tough problems. You might need to look over this a couple times. The more you practice, the better you're going to get. All right, guys, I'll see you next time.